Good afternoon, everyone. Previously, we were seeing different containers that can have different data types. Uh, these containers were just tuples and such. So, list is a mutant. Rest of the things are immutable. So, once we assign some, we can later change. But once we assign some value to a type, it always be that one change. But extent of the same or information on that. After that, we saw how to create a function. Function is having the single thing outside anything. This would be called as a function. You need to remember that everything in Python is an object. So a class would be an object, an instance would be an function would be an object. Every in Python, so, that's called object oriented. So, basically, it's nothing but a set of hierarchies we assign. So it's similar to say, suppose we have planets. Will be different planets surrounding the star. So within our planet, we have different countries. So a planet consists of countries. So what does a country consist of? It consists of states. States would be states, and within that there is some hierarchy till we get to the end of this hierarchy. So basically, a class would be a bit more in the hierarchy level. Above it will the class is also an object that contains different objects. These objects within the class are called methods. Uh, if there is no if these things methods are not enclosed by a class, we'll call them functions. That's basically. So this is not, there is nothing enclosing this, right? So this is just a function. So now for enclosing the whole thing in some object, uh, will convert that, we'll say that thing as method. Uh, this class has this method. If there is no class, we'll just directly say it's a function. So to create a function, we will put this class keyword and we'll have the name. So and the semicolon. So generally class will have instantiation. It's like similar to constructors in other programming. So previously here we'll give here what are the variables that will the arguments that function makes. So similar to that, here we'll mention, we'll make a small function that will say these are all the things that will that this class needs. So here we have def init. Init is the name default name that we use to create some properties to the class. So you need to remember this syntax. So it is similar to the creating a function, but in a class for creating a function, it should always have f. So the name of the function. Here we are creating a constructor. So by default, the constructor name is underscore underscore init underscore. These are also called dundef. So this is just saying that this is the only thing you don't need. This is the naming convention that's used. So after that, you should always put this self. This self is referring, saying that this method is referring to the same class within it. So you just put the self here. Self. This self will refer to this class. and then you can put the same things. You can create the whole thing that you generally use to create a function. We'll have some this def, some name, some arguments here, and after that you'll have some logic here, right? So within the class, if we want some variables, so we should have self dot name. So previously, to create something, we'll take name and it will be coming from outside, right? So to call this function, we have something outside. It will go in this function. So here we are specifically naming that. Whatever names comes in, this is the instance variable. So instance variable is like this class has some instance variable, some variables relating to this class. So this class has some properties for itself. It is not something else. Uh, uh, so to get a name within this class, we always have self dot names equal to the name. So while initiating, we'll put previously we'll put some x equal to the value that comes in. Now we have to put self dot x. So the self dot x says that this variable belongs to this class. Every time further in the more in your logic, every time you want to use this name, every time you need to add self dot name, so that it will understand that okay, this variable belongs to this class. Out of that, you can have any different functions that you can write. So since we are writing functions within a class, they will be called methods. Classes will have methods within them. You can also have, so here a class can inherit from some other class. So inheritance is a topic that will take all the properties of this superclass. So yeah. So here in this code, let's see what's happening. We're creating a class called greeter. So we have an instance variable, some name. This class is taking some name, and we have a method here. So we have method saying def greet. Since within this method we have self. So this is the syntax to create a function within a class. Self, comma, cloud equal to false. Cloud equal to false. This is the same function we wrote here, right? This is the same function. The only thing that is changing is we are here, instead of saying all the properties we have, we will put a self here. This self will take care of all the properties or all the variables that we initiated for this class. So yeah. So this is the same part previously we saw, right? Here we are getting a name from the function. Here similarly we need to put a self dot name. So this self will contain everything that we initiate. So from that self we are getting self dot name. So and this whole part is similar to just the single name part here. Since we are writing it in a class, we'll write this as self dot name. And the same thing, it's the same similar thing. Dot upper is a default method available for strings. So it's like Python has given us class called some str, and here they have defined self comma some some properties are given, and they have self dot something equal to something. They have initiated this. Then they have self def So for this string, we have some dot upper. What will upper do? It will convert all the single thing, all the individual letters in a string to uppercase form. So we have a method here. So call the upper, and it will have some self. This is syntax, right? Comma, some will have some values here, and we'll have some logic here, right? So that will convert things into uppercase and then return the uppercase converted form. So now in this string, to get the to use this function or the method within this class, we use dot. We put a dot, and then we'll get the say this method will be run on the stock we have. So similarly, we can have different functions. Say def. So one more function is like length, then right. So we have some help, comma, some thing here, and we have some logic here that will convert, that will go through the string and return the length. This will return some value. This will be the length. So now this string class has some predefined things that we need, and upper is one of the methods that is available for this class, and this length is one of the methods available for this class. So we can also say that for this object string, there are different methods available. Each method is in itself is an object by itself. So object consists of objects within them. So yeah, so that is the general syntax for how the back end of everything. We can create our own functions. So create a class greeter. Now we have some value. We are initiating the name that a greeter should have. So a greeter should greet someone, right? You need to know the name. So they're getting the name. This is the if allowed is false, it won't be low, it won't be uppercase. If it is true, it will convert it into uppercase and it will return. So now to use this class, we first have to construct an instance of the creator class. So this we need to create a this is the instance of this class. Say greater friend. So here we are providing what are the arguments. Previously, to create to run the function, we are giving properties here, right? Now we need to create a class. This class G is a class is constructed using this greeter. So here you need to put all the things that you write here. These are all the arguments. So here, suppose you have age. So we need to write things like self dot age equal to age, and so let's put in this comma. Some will print some age. Your age is dot line, and to put this thing here, we need to insert this dot format. We should have self to get to this age. Previously, we generally put age right directly. Since this is inside a class, we need to put self dot age. This will return the values in the same, which is the same thing. Just copy this. So yeah. Now you can see by running this, it is asking the missing one argument, positional argument age. So we haven't given, we just gave the name, but here we are giving two values, right? So we need to give two values here so that the constructor can construct the whole class here. So let's give that to some age 42. Let's print it out. See, it's printing the same value that we gave. This is a basic structure for class. I will suggest you to go through one of the best resources in YouTube. So, yeah, this lecture is one of the best lectures available. Since we in the work with like machine learning project, right? Have all sort of time. So this would be one kind of homework for you. Just see one of each of this video is like 1 minute or 2 minute videos you can go through, and you'll have one lecture that will explain the details of everything. Uh, so this is a very like if all the people will go through this lecture, it's a similar kind of lecture to understand the knowledge lecture. So suppose you're giving an interview to someone, the person that is taking your interview will have some syntax for themselves, right? So they will pick up the syntax from someone, some professor or something. So this MIT lecture is widely used by most of the people. If you can understand the words, like if you understand and use the words when you are talking to the interviewer, the person will also understand it very easily. Rather than explaining in many words, you can directly use the same words that were taught in the class, and both of you will be on a same page. This is very useful. So yeah, go through this. Just to type MIT Python, you will get this 6001. So here you can see what are methods, method classes, and these are small videos. Once you have gone through the lecture, you have small videos here. So suddenly, sometimes you might forget what does a method mean, what is a method for. You can directly come here, refresh your knowledge here. So this is the best way. So you can also go through classes and inheritance. What is it? Basically, this inheritance, these all are necessary for programming, but for data science, most of the things have been abstracted for us. So for in machine learning, to understand, like you need to understand why it's running. You don't have to go through each and every single line of code, since a single ML project will contain so many libraries. So, and so much stuff will be there, and you need to have a bit of hacker kind of mentality but you will get down to it and keep working with some model, some training stuff. We'll get to that. These are the very good till this subclass you can go. These are different programming concepts that are like what is big O notation. You have learned, you might have learned in your C program, some programming. So I would suggest you to go through all of these and have them in the back of your mind. It is very easy for you to refer back also. So this is just till now we have been talking about uh, what is Python programming, what different nomenclatures are available for different data types, different data structures, what are the objects, functions, and classes. So while writing ML, there is these are like just the language we ABCDs, and for ML we need to use kind of code. So once you get started with ML, you'll slowly pick up these things. You don't have to worry, but don't miss out on these lectures. You have to go through these lectures at least once. You have free time just to put them in background at that browser. Uh, for me personally, they were very helpful. That's why I'm suggesting all of. Now coming to the main part, we all ML, deep learning or artificial intelligence, every time some kind of math in the background. So we store and work on different kind of ML, uh, like some data, any kind of data will be converted into numbers. Suppose we have weather prediction task. So we'll have temperatures at the previous time. That would be numbers, right? So second thing, suppose have images. One in each pixel in an RGB value. Red color will be some value. Similarly, zero. So that is also one kind of image is also representing some kind of numbers. Say suppose you have some audio data, different kind of frequencies are there. The number of the frequencies stored, and this is also stored as numbers. Right? Everything we did in computers is in some way, in some background or some page level, everything. Yeah, with numbers efficient. So generally in Python we have int and float, right? Then why should we use for our way to some of? So NumPy is a library that takes care of the speed. Generally in Python, list is suppose generally in Python we say list, right? So yeah. So this is a list that we have 1, 2, 3, 4, 5. So each, so if you have an idea how memory is, so there will each part will be of 8. Each thing can 0 or 1 on or off state like this. So this can be either 1 or 0. So initially to store 1, we'll have some notation. 0, so say 4-bit. So 0, 0, 0, 1, 1. So this will be stored here. 0, 0, 0, 1. Say suppose this is only 4-bit. Generally it is 16-bit or 32-bit or 64-bit depending upon your computer. So just say it's a 4-bit memory structure, and we have this memory stored. So initially this list will have a pointer that points to the head of this list. Then after this end will also be pointing to some other position. So this other position will go to the second 0. So second 0 might be somewhere, can be somewhere here. Second element. So since 0, it is 0, 0, 0, and 0. So this will point to this in somewhere in the location. Depending upon the availability of location, Python will assign this inside itself. So to get say till the fourth value, you need to initially start at this thing, then go through this, where is the next thing pointing to, and after all the jumps, one, two, three, after three jumps, you will get to the element that you want. So because since if we store them continuously without saying that we need to go here, go there, just saying that it will always point to the next location of the memory will contain the say next element. So this is called contiguous memory allocation. Python generally doesn't do this. So to do this kind of contiguous allocation, NumPy library. So in C and C++, there are different and same implemented by the NumPy curators. This is basically doing mathematics in NumPy. So let's import NumPy as NP. See, as NP is like anything. Suppose I put I name the library Manoj Kesani Mathematics Library to Mathematics Company. This is the name of library. You need to do anything. You need to type it all the name every time, and you do dot and inside the library. Rather than the whole thing, you can just abbreviate it as, you can put import NumPy as NP, or you can put anything that you like here, NP, NX, or number, or anything like that, except the 28 keywords that we put them aside, right? Except that we can put as anything here. It's just to put as an abbreviation. So in Python, we call it list. In NumPy, we call it an array. So array would be a contiguous located list. It's same as the list in Python, but just it is contiguous in memory. To create a list, Python in backend, it will say we want 5 elements. It will locate 5 empty spaces or unallocated places, and it will put the pointers accordingly, and you can use that list. So if we create an array, it will choose a specific area that has all the 5 places available, and it will return as will put the values that we want in that place. Yeah. So here we are saying a equal to np. So here we imported that is NumPy library as np. So np dot array. So here see here we have dot array. See the NumPy method. So previously they have written some method called here def. This class NumPy, they have some method called array. So what does this array have? This needs this kind of syntax. So it is given a list. This is generally Python list. It will convert this Python list into a NumPy array, and it will be assigned to a variable a. It is the same. So type of a is previously it was a list. Now it will be NumPy ND array. ND means n-dimensional array. The dimension of this is 1 dimension, right? Just one line. If we have square matrix, it will be 2 dimension. If we have cube thing, it will have 3 dimension. Then we are saying a dot shape. Now there is one more method available for this a equal to NumPy dot array. NumPy dot array is a class that we have, and this class has a method called shape that will return as the shape. So 3 comma 0. So nothing is there, means it's 3. Only 3 elements are there. If it was a 2D say 3 cross 4, it will be 3 comma 4. And we are asking what is a of 0. A of 0 is 1, a of 2 is 2, and a of 3 is 3. So similar, this part is the same syntax that we used for our list, right? So indexing to array is similar to indexing to a list. Now we are trying to change uh, a of 0 equal to 5. Previously a of 0 is 1. So this is the same syntax that we used to manipulate elements within a list. So this we are getting C. Print of a equal to 5, 3. The same thing, but in just or we are encapsulating everything in this NumPy class to just make everything faster. Yeah. To create a two-dimensional array, so we are giving the first row as a list, second row as a list, within a single list. So list of list. If you have three things, it will be 3 cross 3 elements. Here we give two lists, right? So yeah, so this can be, say suppose we have a matrix like this. One row, second one, third row. We need to create an array. We'll give this list. There will be this will be a list of lists. This row will be here in comma, and we'll have one more list. This whole thing will be here, and now this whole thing will be here. So one more thing, if you have used MATLAB, Python is a row major language. In MATLAB is a column major programming. The basic idea is we'll take all the elements in one row and put it first. In MATLAB, it is like we'll take the elements of the first column and we'll put like this. It's the same stuff. The creators of Python used this like row major concept. The creators of MATLAB used this column. It's just some convention that was. So here we are creating this same thing, np.array, a list of lists. This list of lists contains the elements within each row. Yeah. So 1, 2, 3 is the first row, 4, 5, 6 is the second row. So similar to previously we got b dot shape. B dot shape is like there are 2 rows and 3 columns. We have 2 rows and 3 columns. So you have to index through each thing. So what is this position 0, 0? So first thing will be row wise, row number, and second will be the column number. P of 0, 0 is like first thing here. 0th and 0th column. Where P of 0, 1 means 0th first column. So it is 2. P of 1, 0 is like first. Sorry. Since Python is like previously we know, indexing in Python starts with 0. So 1 is the second row. Second row and 0th element. It is like second row 0th element is 4. This is the way we indexing. It's the same thing. Since we have 2D, we'll need to put 2 elements like which row, which column. We have 3 dimensions, so we'll put the third number. So we have one of the main things, like if you forget, say suppose what are the different methods available for me to do something. So we can say here we have a, right? A, we have instantiated a. So let's put dir of a. So this is like the directory. What all things can order methods are available for this class. You can do this for anything, any class. So there are different Dunder methods. You don't have to worry this about this Dunder method for data science or this is like the programming stuff to run everything. This is similar to the that constructor classes. So easy. So there are so many things available. So, so to all any arguments, argument, uh, these are all different methods available for paste type, click, copy, data, dump, retype. So we have here shape is right. So in this list we have some shape. Yeah, here it is. So to know what each and everything will do, you can go to the NumPy documentation and read through what does everything do. You don't have to remember everything. So you need to like what can be done. You just need to understand what does max do. It will return the max element. What does min do? It will return the minimum element. What does mean do? It will take the average of everything in the array and it will give out the mean value. So there are like different methods to return for single everything. So don't forget this dir uh, directory. Dir of anything, any class you put here, it will return all the available things. Let's say here we wrote one class for ourselves, right? And then we injected a z. Let's see. So here we wrote, we did not write any of these things. So see, there are so many things available for itself. Like by default, Python gives us all of these things. What did we do? Is greet. So here is the greet. So age is one variable and name is one variable. These are the self things that we provided here. Name, age, and this greet. So these are instance variables. These are in method. This will return all the instance variables and methods available for that class. So yeah. So now I'll go through different functions that are available that we most commonly use. NP dot zeros of this is the shape of what do you want? Which shape do you want? So zeros will create all the entries of that matrix is zero, and here we do give the shape of the matrix that we want. So return a matrix that contains all zeros. So similarly, NP dot ones. So it will return all the matrix containing ones. So we want one row, two columns, right? So it is like 1, 1. So if you want by any like zeros and ones are most popular, mostly used. You want to create anything for yourself, like it's a say of 7 should be all the matrix element should be of 7. NP dot full the uh, the method for doing that. And here we have to give the shape and we need to give the number that it should be filled. So NP dot full the shape and 0 is the same thing as NP dot 0. So NP dot I is like the identity matrix. So identity matrix is always a square matrix. So we'll just put the value. If you have 2, it will be 2 comma 3, 3 comma 1. By default, it understands that it should be a square matrix and it will create a matrix of that size. So suppose we have a I of 5. Will create a 5 cross 5 matrix that has ones in the ones at the diagonal elements and np dot random dot random. So within np there is some class called random. So within that, so if you hover over this, we have some information about that number, random number generator, and different things are available. This functionality is because of Cola. So that's why you need. I suggest you to get started. So you can go through here, read through what is the different, like what are the thing about this class. So see here we have so many things available. So you don't have to learn everything. You just have to know. By practice you will understand. So within that random class, we have a random method. What does this random method do? It gives us a values with 0 to 1 with the shape that we defined here. So we defined 2 comma 2 square matrix size, and it will populate the elements with some random values 0 in 0 and 1. These are like few like methods that we commonly use in data science. So, now let's see how to index through an array. This is the same kind of indexing that we did, but in higher level. Then suppose we have this array 1, 2, 3, 4, and we need to index. So if we don't put anything before the colon, it will start from the first like 0th element. Right? It will go to this number, but not including this. So we are saying so this part would be the row. This part would be the column, right? So we are saying take the first row or take the second row, but not the third. It will take this first row and second, but not the third thing. And now in columns, we don't want the first column, the 0th entry. We want first, second, and third. So we picked these two things, and in that we are vertically doing this thing. So we need to take second column and third column. First row, second column, and third column are 2 and 3. Okay, what like second row, second column, and third, comma 7. A of, so in list everything is continuous, right? So we just need one number. For NumPy, we need to have how many our dimensions we have, those many numbers. These are the, say we have, like this might be the row, this length and width. We have 3 dimensions. This would be length, this would be width, and one more thing would be the height. You have volume, 3D volume. So each volume you are trying to select a different thing. So similarly, previously we can assign anything, right? So you can put values and like not the first entry, but to be 77. We can also make the size. So have this. For example, we have a random. We have so row 1. What is row 1? You want first row and all the columns in that. So in same value can be written like. So if we put till slice just by doing 1 to 2, take 1 right, then it will create a list of list. Or else it will just return a list. So here you see the list of all the entries in this row. So this is the second row, right? It is giving the whole thing as a single entry. If we are saying from 1 till 2, excluding, it will return this part within a list. So by practice, you will understand the. So if you want a list of list, it is like we'll use 1 to 2 rather than saying just 1. So suppose if you are doing seventh thing, we'll put 8 6, right? You just put a 6, it will give the entry there. We put 6:7, then it will return it in will persist the dimensions that we are doing. Suppose if you have 3 dimensions, and it will return a list, but the dimensions are changed. See, here this is the 4 dimension thing, one dimension with 4 end. Here this is like in 1 dimension there are 4 elements. So I suggest we always use this kind of indexing because errors will come errors like this part just by putting this one. At some point of time in your code you are trying to get the shape of the array that extracted the stuff from. If you put the one, it will give out the index shape like this, but the shape is 1,4. Right? So in 1 dimension there are 4 entries. This kind of indexing will give there are 4 entries. So if your code depends on the shape, then you need to put this thing just in case someone else is reading the code and just by seeing this part they'll understand, okay, this is a part of a slice of a bigger matrix. The matrix has some size related. If you have just this part, people might think that it's just a single list, a single 1D array. So the similar thing also we can do with columns. So we have example of integer array indexing. So integer array index that will return array till we have the shape. So in this example we can see that the integer array is equivalent to the same part previously. You want to like 0, comma 0, 1, comma 1, 2, comma 0, things like that. So rather than doing that, we can have 0, 1, 2, 0, 1, 10. To shared in your both. So if you slice a matrix, it will return a view of the matrix. If you do some changes on that, reflect the main original matrix. This is the stuff like mutability, just by changing, going there and changing. This this part is not like rather than saying 0th element 1, we can use a matrix, similar matrix of our original shape, but it has some entries like true or false. We use this kind of matrix to do our indexing. It will return each and every element where it is true. So this will return the values in. So this here print. See here we have this A element and the bool of this thing where A is greater than 2. Where is A greater? These two are not. So this is the false. This is false. But the rest of the things are true. True. So these are like just like each and every element greater than 0. You can use matrix that we have that was returned the Boolean index to index within the matrix again. So print A out so this thing. So now we are indexing A of bool index. This is a matrix containing true or false value. Where this value is true, it will return. Where it is false, it won't return. So we created this using this greater than is a greater than 0. Each entry greater than the element. This is same. So if A of where A is greater than 2. This is printing all the values where A in the matrix A where each element in A is greater. You can either do this thing or create a Boolean matrix that will say should it return or not. Both things will return the same. Now coming to data types, there are like so many different data types in Python, in NumPy. So there are objects, so there are floating points, ints, there is like the float 30, float 16, 8. How do we want to represent our data? So in Python, it depends on the programming, like Python package that you install. Or it might be 30 or 64. If you have 32, or get all the like values from 32 till 1. If you have 64 bit, it will be from 60 to 30. NumPy has so many other implements that are standardized by most of the world. So you might have seen like each letter will have some ASCII character, right? So there are some standardized like data formats that are that general programming standards use, and NumPy utilizes those things to make things faster. So like most of the times we have in the end float into 62 or 64 float 6 is the main way that we work with. So if we don't have available for memory, we'll use 30 and go through the documentation. Is very we rarely use like we generally use the default thing, right? But sometimes to get in like some rare data types, you can come here just to have a glance and see. So just by putting comma d type, this is an argument that we give. So d type equal to np dot into 630 or 62. If you put into 32, it will store them as info. Yeah, so this is the same mathematical notation that we are familiar with in other programs. We have initialized this array of this some arrays like this, another array is like just x plus y. It will directly go through each individual array and it will add. And the same thing we can do with the method also. So dot add is also the same thing that does the same thing. Can either do this thing, it will go element wise, and you can or else you go through the add method in by and it suggests you this is the general way that we write in our math also, right? This is similar to what we how we think. So minus is also x minus y element wise subfunction. Multiplication is also element wise multiplication. So NumPy has a square root function they have written in like that, and we also go through individual square root. So the main thing that we does the dot product. So the say something like a vector x is I think vector y is we want to have this dot product with double initiated some array. The dot product is will go through different elements. It will do the product, and at the end it will add the whole thing. So either you can put v dot dot of w, or you can do numpy dot of w. And we also can do x dot t. He will do the transpose of the matrix. You remember the non-zero square matrix, but in NumPy there is by default it's some pseudo transform. Don't have to study data science. I don't think so necessary. It's just a small detail. We generally say that transposer matrix should be a non-zero determinant. There are some techniques like in uh, like actuality we cannot represent all the numbers in exact precision. So might be a exact like suppose say some 37.689, so it has some 70 million decimal points within it. We can't represent that accurately now. So we'll truncate it at some point, and if we try to get the determinant, it won't be zero. So there are some things that are done in back. Just know that this transpose is general transpose that we get, and if the matrix is zero determinant matrix also, it will give out a response. Technically, when we do this thing on paper, we'll just say it's a zero determinant transpose. So broadcasting is a simple like a small uh, say suppose you have a matrix like this. So there are some entries here. And you want to add here 1, here 0, here 1, here 1, here 1, here 1, here. You want to add to the elements here on this line. If you want to add, you'll say create a matrix A from a matrix B. This B will be like 1, 0, 1, 1, 0, 1, 1, 0, 1. So this A matrix will be some values here. Yeah, right. So, but here you see, right, 1, 0, 1 is always repeating. Rather than just doing this, we'll just put a B equal to just a single line, 1, 0, 1. And we will say A plus B. Then what happens is this whole thing will be replicated twice more. It will be replicated to make the format similar to the first this for A's format. We just repeating rather than just saying. We don't have to write the whole thing. You can just put the same thing, and Python intelligently will extrapolate the thing, and it will return values to us. One second. So I think we're almost out of time. I'll just say there are some things that are still there, but we'll go through that in the next class. But I want to show you the why are we using NumPy rather than using the old just the list. So suppose we have we'll run this part. Say we have some array of A that will contain some uh, 10 lakh, 1 million entries in it, and B is also 1 million entries in it. If we want to do a dot product here, say this percent time is something related to this notebook, that will say how much time did it take to run this cell. So say we have two arrays, each containing some millions of numbers. We want to get the dot product of these two vectors. We saw, right? See, some vector C equal to some. This will be a scalar. Dot product of two vectors will be scalar, right? So C will be some number. C equal to np dot of a print C. Right? So here, this is the value that will return like some this is dot product of a comma b. How much the total time it took is 3.2 milliseconds. So if we do the same thing in by Python, we have to do some for loop, right? So, so dot product of two vectors a comma b is like, so here we have elements comma elements and same number of elements here. So we'll take the same index values, we'll product them, and we'll then add all the products, right? So the same thing. So initially we have the sum equal to 0. Initially there is 0. For I in range, this length of all the number, we're going, this I will give us the index for I variable in iterable. Some iterable, that is saying from 0 to some terminal. What is the length of this array? That will be the index. So we need the product, right? So is a of I dot b of I is saying, okay, first take the 0th elements of both the lists a comma b and do a product, and then the initial is the sum is 0, sum plus equal to product. So each time we are looping through this, this sum will be increasing. Will like sum plus equal to is the same thing as saying sum equal to uh, previous sum plus product is the same thing. That's yeah. So now we are doing product and then adding to the previous stuff, and then we'll finally print the sum. See, we got the same answer from the previous thing, but the time it took is like some 700 milliseconds. Previously, it is just 3 milliseconds, right? So it is like some 200 times faster. NumPy is like 200 times faster rather than our internal loop. So this is the main reason that we are using NumPy for our projects or anything data. I hope this part was clear. Why are we using NumPy rather than all the things that we spent this much time learning? It took like 2 classes on how to do this all the things, but NumPy is faster. Yeah. So in data science, we use NumPy library. In any other some backend where you want to use Python, you can use this. Thank you guys. Bye. You can ask me questions. You can. Thank you.